I'm sharing my screen. Today we'll start with one more concept. That is, in the last class, what you have seen. In the last class, what you have seen? Can anyone say? Oh, data flow modeling we completed, no? Okay. Data flow modeling completed. We need to do with behavioral modeling. Okay. Yeah. Okay. 1 second. So behavioral modeling. We'll start with behavioral modeling. Okay. So we start with behavioral modeling. So behavioral modeling means we are focusing on the behavior of the circuit. Okay, so we are focusing on behavior of the circuit. That is behavioral modeling. Okay, so we are focusing on the functioning 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 or behavior of a system. Behavior of a system. Okay, behavior of a system. So here you have procedural blocks are there in the behavioral modeling. You have procedural blocks. Okay, what are the procedural blocks? You have you have initial, initial block, and always block is there. Okay, procedural blocks, always block. Okay, we'll discuss about this if, initial block and always block. And next you have procedural statements. Okay, so what are the procedural statements? So you have a procedural statements. Okay, procedural statements, procedural statements. Procedural statements are like conditional statements. You have conditional statements. So what are the conditional statements? You have if else case, if else and case. Okay, this is the conditional statement. And next you have looping statements. Looping statements. Looping statements. In this looping statements, you have while loop, for loop, repeat, forever. Okay, while loop. Okay, while and while loop, for loop, repeat, repeat, and forever. Okay, this we'll discuss. Okay, what are these statements? And next you have procedural assignments also. Okay, procedural assignments you have two types. Okay, those are blocking and non-blocking assignments. Okay, that also we'll discuss. Procedural assignments. Okay, procedural assignments. So procedural assignments you have one is blocking assignments. Blocking assignments. The symbol for blocking assignment is this is equal to blocking assignment, and next one is non-blocking assignment. Non-blocking assignment. Okay, assignment. Non-blocking assignment is uh, less than or equal. Okay, this is non-blocking operator. Okay, is it fine? What are the means procedural blocks and procedural statements? All those things. Shall I move forward? Hello. Give response so that I will move forward. Anyone? Anyone? Is it fine? Okay. So next, we'll see first initial and always block. So initial block means so Verilog is a concurrent language, no? So initial block will execute only one time. Okay. So first we'll see about the First, that is initial block. Okay, what is this initial block? We'll see. Okay, so initial block. So initial block means this will execute only one time. Okay, suppose if you see, um, so initial, let us take initial, and if it is multiple statements are there, you need to write begin and some lines of code. Okay, some lines of code. This is some multiple lines. If you have multiple lines, okay, so multiple lines, it should be end with the end. It should end with end. Okay, end. Okay, so here you need to use begin and end if there are multiple statements. Okay, so here Verilog is a concurrent language. So that means whatever the instructions within the begin and end, if you are using blocking assignment, those are sequential in nature. Suppose if you take one more example like module module initial begin and end. Okay, again I am writing initial begin, some multiple statements are there, and end module. So we know that Verilog is a concurrent language. Okay, we know that Verilog is parallel language, or we can say that concurrent language. Okay, concurrent language. So all the instructions will be executed parallelly. Okay, we can say that parallel. So parallel in nature. Parallel in nature. Okay, so here this is one block and this one is another block. Okay, so which block will be executed first? Can anyone say? Hello. Which one? Block one. So Verilog is a concurrent language. Both blocks will execute parallel. Both blocks will execute parallel. Execute parallel. Okay, parallel. Okay, so this is one example, and one more example. Suppose if you take example 2. Okay, this is example 1. Let us take this is example 1, and example 2, if you take, suppose you have module initial begin and end, initial begin and end, and I am writing always also, always begin, end, and end module. So this is block 1 and this is block 2. Always is block 2. So which one will execute first? Both blocks executes parallel. Both the blocks will execute parallel. Okay, execute parallel. Okay, parallel. And third, if you see, you wrote example module example. I'm giving assign. Let us take one statement. This is block 1 and initial. Suppose this is block 2 and always also I'm writing. Okay, always, and this one is block 3. So now which one will be executed? End module. Here also both blocks will be executed parallel. Okay, here also all the blocks will be executed parallel. Okay, then you can ask what is sequential, sir? Okay, so what is sequential? Now what is sequential? Okay, I will tell you. So is it fine? Do you understand? Shall I move forward? What is sequential? Okay, sequential means here begin. Okay, so here a equal to 1. Okay, a equal to 1 and a equal to 0. Okay, so this is we call as blocking assignment. Okay, what is this blocking assignment? So blocking assignment is when this instruction is executing, next instruction will be in the blocked state. Okay, like if you correlate with so that this is sequential. Okay, end and end module. Whatever the statements within this, these we can call as these will execute sequential or serially. Okay, so if you correlate with real life example or real life example, you have suppose a single road is there, or if you have some fast tag. Okay, so in the fast tag, so one car is so when one car is stopping, so there is no overtaking. Okay, there is no chance of overtaking. After one that car pays the tag, then only the gate will open and that will move. Again, next car will come. Okay, so that car tag, whatever the paying that tag, fast tag should complete. Okay, so during execution of this one, this will be in the blocked state. After executing this one only, this one will be executed. Okay, so that is a non-blocking assignment. And initial means it will be executed only one time. Okay, this will be executed at zero time units, and this is non-synthesizable. Initial block is non-synthesizable. Non-synthesizable means we can't convert into hardware. Okay, so like this. Okay, so this is blocking, and here yeah. So here if you see one more example, suppose module example module example, initial, um, suppose you are giving a equal to 0. Again I am writing initial and b equal to 1. Okay, when you are using behavioral modeling, you need to use a procedural block, either initial or always block you need to use. Okay, end module. Okay, so this is block 1 and this is block 2. Okay, so both blocks will execute parallel. Both blocks will execute parallel. Okay, both blocks will be executed parallelly. Okay, suppose if I take one more example, is it fine? Do you understand? Please give response so that I will move forward. Okay, yeah. So here let us take one more example module. Let us take example 2. Okay, example underscore 2, and I am writing like I am declaring reg a comma b comma c and where d initial begin begin. I am giving d equal to what? 1. End and end module. Is this code will compile? Please tell me. Is this code will compile? Please tell me. Why? What you are telling, I am not able to understand. Initial d equal to 1, I initialized. Okay, I initialized. After begin, I initialize d equal to 1, end and end module. So if it is compiled, how it will compile? If it is not compiled, why it is not compiled? So see, it is not compiled. Okay, why? Because the reason is what is d? Which data type? Is this is a Y data type or net data type? On the LHS, what is D? What I initialized? Where data type? Okay. So you need to remember that in procedural blocks, okay, in procedural blocks, whatever the LHS is there, okay, procedural blocks on the LHS, okay, on the LHS side, we should only use rich data type. We should only use rich data type, okay. We should only use rich data type, okay. And RHS side can be any data type, okay. It will take rich data type, wide data type. All data types are correct, are accepted. All data types, all data types are accepted. Okay, all data types are accepted. Suppose in place of D, suppose if you are giving A means this will, code will compile. Why? Because A is a rich data type. Okay, in the LHS, A is a rich data type. It will accept. Okay, or in the LHS, it can be integer data type also. It can take integer also. It can take integer data type. Okay, it can be rich data type or integer data type. Okay, is it fine? This is very important. So portal connections we already seen now. Portal connections. Have you seen a portal connection or not? For the design, so this is like a test bench. So this is my TB on top module. For design, you have inputs, no? Input should be which data type? Net data type. Outputs can be what? Outputs can be, it can be net data type or it can be rich data type. Okay. So depending on the means modeling style. Suppose if you are using data flow modeling, all the inputs and outputs should be net data type. Okay. And if it is behavioral modeling, input should be net data type and output should be rich data type. Is it fine? Okay. And next, initial, begin, and some multiple lines of codes are there, and the end. Okay, so this will execute only once. This will execute, initial will execute only once. Okay, only once. So here this initial is going to start at a t equal to 0, at t equal to 0, and it will execute only once. It will execute only once. Okay, and this is non-synthesizable. Okay, not non-synthesizable. We can't convert initial block to hardware. It is non-synthesizable. Okay, so then where we are using means we are using the initial block only, we are only used in test bench. As this is non-synthesizable, where you are using this initial block means we can only use in the test bench only. Okay, is it fine? Do you understood about the initial block? Okay, yeah. Next, delay operators. So if you delay operators, if you take, so delays we will discuss separately. Delay operator. So delay operator. So ash is the delay operator. This ash is nothing but the delay operator. Delay operator. Okay. So so let us take one example. Initial, begin. Initial, begin. I am giving a equal to 0. Okay. So a will be displayed at t equal to how many time units? A becomes 0 at t equal to how many time units? At a 0 time unit. Okay. And next, ash 5, I am giving a equal to 1. Okay. So after, so that means after 5 time units, a becomes 1. After 5 time units, a becomes 1. Okay. And ash 10, I am giving a equal to like 10. Okay. After how many time units the a becomes 10? After this will be added 5 plus 10, 15 time units. Okay, that will be added. Here 0 will be there. At t equal to 0. Okay, this will be executed. Okay, and after that we'll discuss about these delays are there. Inter-segment delay, intra-segment delays. So b equal to some, if you take 12. Okay, after how many time units the b becomes 12? After 15 plus 5, 20 time units. 20 time units the b becomes 12. Okay, is it fine? Shall I move forward? Okay. Yeah, I'll add one more page. So next we will discuss about so we completed with always block, no? So next we will start with we completed with initial block. Next we will start with always. So what is the meaning of always? Can anyone say? What is the meaning of always? Continuously or every time. We can say that every time, or we can say that forever, or we can say that repeated. That is always block. Okay. Suppose if you take the basic half adder circuit, we already seen the half adder circuit. Half adder have how many inputs and how many outputs? Two inputs and two outputs, sum and carry. Okay. So you know the truth table also. So the A, B and sum and carry. Okay. So 0, 0, 0, 1, 1, 0, 1, 1. Okay. So sum 0, carry 0, sum 0, carry 1, sum 1, carry 0, sum 0, carry 1. Okay. So I need to write the Verilog code for this half adder. Okay. How to start module. What is my module name? Let us take HA. Module name is HA. I need to declare input A comma B comma output. If you are using procedural blocks, you need to declare the output with reg data type. Reg S comma C semicolon. Okay. So always at the rate A comma B. Always at the rate A comma B. Okay. This is sensitivity list. Okay. So, so this is sensitivity list. Sensitivity list. Sensitivity list means if there any change in the input, there is a change in the output. Okay, that is the sensitivity list. Okay, and next mm, begin S equal to what? A XOR B. Okay, and carry equal to A and B. Carry equal to A and B. End module. End module. Okay, so like this we can write the code within the always block. Okay, and this is always block. Mm. Always is synthesizable. Okay, always block is synthesizable. Always block is synthesizable. We can convert into hardware. So that's why we are using always block in the always block for the design. Okay. Suppose if you are writing always at the rate, let us take a comma b and y equal to a. Is this code will execute? Is this correct? Is this correct or not? I am asking. Please tell me, waiting for your response. This will be not correct. Why? Because here, so you need to use these both sensitivity list. Here A you are using, but B you are not using, no? Okay. Suppose if it is always at the rate, suppose B. Okay, always at the rate, let us take A. Okay. So Y equal to A. So A only used. Okay. So then this is correct. But B you are not using in the code, that is not correct. Okay. And next is implication operator. So implication operator if you take, mainly suppose if your design have more sensitivity list like 250 inputs or 500 inputs, okay, or more than 4 inputs. Okay, suppose if you consider always 4 inputs are there, how to write in the sensitivity list? A comma B comma C comma D. Okay, so in order to represent this, so I can use this implication operator, that is asterisk. Okay, so always at the rate, if you apply star in the sensitivity list. So that will be applicable for all the inputs. Okay. So all the inputs. So the syntax will be for like this. Okay. The syntax will be so always at the rate sensitivity list. Sensitivity list. Okay. Sensitivity list and behavioral statements. Behavioral statements and end. Behavioral statements and end. Okay. Did you understood the implication operator? Any doubts or queries? Hello. Which one? Uh, these are the inputs. Suppose your design have the inputs. These inputs, this sensitivity list is nothing but these are the inputs. Okay. If there any change in the inputs, then that output will change. Okay. Suppose if you are writing for like sequential circuit, D flip flop. Okay. How to write? So D flip flop will be triggered only during the passage of clock or negate of clock. If it is triggering only at the passage of clock means always at the rate. What is the sensitivity list you need to write? Passage of clock. This is the keyword, passage of clock you need to write. If it is a negate of clock, how to write always at the rate negate of clock. Okay, negate of clock. So here, suppose your design have like 250 inputs are there or 500 inputs are there. This 250 and 500 inputs you can't declare in the sensitivity list, no? So in that situation, you can use the sensitivity implication operator, that is asterisk star. So when you apply always at the rate star means it will be applicable for all the inputs. So that means if there any change in the input, there is a change in the outputs. Is it fine? Do you understand? Okay. Yeah. So blocking and non-blocking, as I told you. So blocking means, so if you see the blocking example, so blocking assignment. So if you see the blocking assignment example, so module example, initial begin, begin. Suppose a equal to 0. Okay, a equal to 0 and hash 5 a equal to 1. Okay, and hash 10 some a equal to 2 I am giving. Okay, 2 I am giving. Okay, end module. So blocking means what? When this instruction is executing, when a equal to 0, this is executing. This will be in which state? Blocked state. Blocked state. Okay. After executing this instruction only, then the compiler will execute the next instruction. After completing this execution only, then compiler will execute this instruction. Okay, that is blocking. Okay, like a single road I told you, no, that is blocking. And if you see the non-blocking, so non-blocking means all the instructions will be executed parallel. Okay, like if you say like your highway, two sides vehicles are moving parallel. Two sides vehicles are moving parallelly. Suppose initial begin begin. I'm giving non-blocking a non-blocking with 1 and a non-blocking with 0 and a non-blocking with again 1. Okay, end and end module. So here what happens? This all will be executed parallel. Executed parallel. Parallel. That is non-blocking. Okay. So here if you see the difference between blocking and non-blocking means, so if you see the difference between blocking and non-blocking, blocking, blocking assignments. Okay. So blocking assignments. Okay. And non-blocking assignments. Okay. So blocking assignments and non-blocking assignment difference is, suppose If you are giving initial, begin, some a equal to 0. Okay, some a equal to 0. So here whatever the 0 value is there, okay, so whatever the 0 value, that 0 value is directly stored in a. 0 is directly stored in a, stored in a. Okay, if it is non-blocking, what happens means initial, begin. If I am giving a non-blocking with 0, first what happens means this 0 will be stored in temp register. 0 will be stored in temp register. Again from the temp register it will come to a. Okay, so let us take one example. Suppose if you take one example, this. Okay, so always at the rate passage of clock. So a equal to, I am non-blocking, blocking with 0. Okay, so during every passage of clock, what happens, the whatever the value of a is assigned with 0. Okay, every passage of clock during that event. So every passage of clock, okay, during this passage of clock, a will be assigned to 0. Okay, suppose same thing if you are writing in the non-blocking, always at the rate passage of clock, a is non-blocking with 0. Okay, first 0 will be stored in temp register. From the temp register it will be stored to a. Okay, it is like what in the sequential circuit we already seen. It's like a D flip flop only. Okay, D, and here there is a clock. Okay, and here you have Q and Q bar. Okay, from this what you can say, blocking assignments, whatever the blocking assignments are there, we are going to use in the designing of used for sequential circuits. Sorry, used for designing combinational circuits. Blocking assignments are used for designing combinational circuit. Okay, and these non-blocking are used for sequential circuits. Did you understood this? Why we are using the sequential and combinational, and what is non-blocking and non-blocking assignment? Is it fine? Shall I move forward? Hello, waiting for your response. Okay, so we'll see with suppose one example, positive edge trigger D flip flop. So for this positive edge trigger D flip flop, how to write? So always at the rate passage of clock, Okay, begin. If reset equal to 1, if reset q is initialized to what? Q is initialized to one tick binary 0. Okay, else q is initialized to d. Q is initialized to d and the end module. Like this you need to write. Okay, before that module is there. Okay, like this you need to write. Okay, mm, and we see in the conditional statements, no? So one is if else statement. Okay, so if else statement, how the if else statement will look like? So if it is if else statement, if condition, okay, I will change the next. I will go to next paper. Yeah. So we are discussing with procedural statement. In the procedural statements, what we discussed first here, first if else statement we'll see. If else, okay. If else, if you see, if condition, okay, begin, okay, code executes the execute if condition is true. Code executes if condition, whatever the condition is there, condition is true, okay. Else, okay, end, begin and end, else begin, code executes, code to execute if the condition is false, if condition is false, false, and false, end, okay. So if we see one example by using for loop, I'm using like so example, if you take one example by using if else statement, I can draw like mux also, okay. So mux how to write, so here I will write, so module, this you see the program, you module mux input, what is my input, input a comma b, and output reg, this is you are using procedural blocks, no, you need to declare it output reg y, okay, output reg y, and always at the rate, what are the inputs, sensitivity list, here s is also there, selection line, okay, a comma b comma s, okay, always at the rate a comma b comma s, this is the sensitivity list. Begin if s equal to s, logical equal to 1 tick binary 0, okay, y equal to what, a, okay, else y equal to b, okay, end and end module. So this is the example for what? Example for example for if else statement. Okay, if else statement. So I can write in the Vivado also. Okay, this mux code I can write in the Vivado also. Just I will show you. So I am opening the Vivado tool. One second. So one second. So first project, new project, next, and my project name is multiplexer. Okay, multiplexer, and go to this, uh, so here this one, yeah, this one RTL design using Xilinx Vivado, next, and create the file. So my project file is underscore